All right, we're starting off here with Chapter 2. Okay. Here are all the sections that we're going to cover in Chapter 2. We're not going to do all of these, but we'll be doing most of those. And here's the really important part, the vocabulary words for Chapter 2. If you have your vocab sheet, get those filled in. If you don't have your vocab sheet yet, get those down on your notes and then transfer those into the vocab sheet when you get it. Okay, give you a few seconds here. You can pause the video and get those down and then press play when you're ready. Okay, a good little warm up here before we start 2-1. Okay, so this is some review on some of the properties that we learned in Chapter 1. So if we look at number 1, it says circle the multiplicative inverse of 1/2 and underline the additive inverse of 1/2. Okay, so multiplicative inverse. Multiplicative inverse, that would be what number would you multiply 1/2 by to equal 1? Okay, so multiplicative inverse, what times 1/2 would equal 1? And that would be 2. 2 times 1/2 would be 1. What is the additive inverse of 1/2? What number would you add to it to make 0? What would you add to it to make 0? So 1/2 plus what would be 0? And there it would be negative 1/2 added to 1/2 would equal 0. Okay, all right, pause your video and answer number 2. All right, hopefully you said the multiplicative inverse is negative 1/3 and the additive inverse is 3. 2-1, solving one-step equations. You've done a lot of this the last couple of years in math already, so it shouldn't be a major challenge for you. So our goal is to solve one-step equations with one variable. So we're solving for a variable, finding a solution. Do not get overwhelmed with the vocabulary here. First, let's make sure we identify the vocabs that are on your vocab sheet. So there's one of them, equivalent equations. Okay, and the other one is inverse operations. Those two are on your vocab sheet. So make sure when we talk about those, you take special notes on those. Now, like I said, don't get overwhelmed because this one, that one, and that one are extremely simple and non-necessary for putting them in our vocab. Okay, and we'll talk about that in a little bit. And then, of course, we'll also talk about isolate. So, the first vocab in our lesson here, the one that's on our vocab sheet, equivalent equations, is right here. Okay, equivalent equations are equations that have the same solution or solutions. Okay, and then says you can find the solution of one-step equations using the properties of equality. And we're going to talk about how making those simpler because those are the ones that are circled in purple up here. Okay, so here's your properties for addition and subtraction. Basically what they're saying here is this. If I do something on one side of the equals, then to make it equivalent, I have to do it on the other side. So if I add 3 on the left, then I have to add 3 on the right. If I subtract 3 on the left, then I have to subtract 3 on the right. Okay? So, isolating a variable. How do I isolate a variable? Well, let's make sure we understand what we're trying to do. So on the previous page, there was a lot of stuff going on, but hopefully you recognized something familiar from the last couple of years of math in terms of algebra. So if I have x plus 4 equals 10. Now, we used mental math in Chapter 1 to solve this, and obviously the one that's this simple, you could easily use mental math as well. But we're going to use our algebra rules so that when the numbers get complex, we won't have any problems. So here is our isolation. We want to get x all by itself. So we're going to look at all the operations that are happening at x. What's happening to x in this case? They're adding 4 to x. So we're going to reverse, which is just like inverse. That's our inverse operations. Okay. and then balance it on the other side so it's equivalent. So what's the reverse or inverse of adding 4? You would say subtract 4. If I subtract 4 on the left, then I need to subtract 4 on the right. Therefore, I have isolated x. X is all by itself. I have one x right there on the left. That's what I wanted. And if I do the math over there, x would equal 6. That's how we would isolate a variable. We're going to reverse what's happening to the variable and balance it on the other side of the equals. Okay, so let's practice some very simple problems in terms of one-step problems. So let's start with number 1. Okay, in number 1, we're going to isolate or solve for p. Okay, notice it says solve up here, right? So we want to get p by itself, so we're going to reverse whatever is happening to p and balance it on the other side of the equals. So what is happening to p in number 1? They're subtracting 8 from p. What would be the reverse of subtracting 8? It would be add 8. And then I have to balance that on the other side of the equals to make it equivalent. So I added 8 on both sides. Therefore, I've isolated p. P is all by itself. And over here, if I do the math, I end up with p equal to 14. Okay? I want you to pause your video, and I want you to do numbers 2 and 3 real quick. Okay, so let's look at number 2. How did you do? Should have subtracted 5 and balanced that on the other side and ended up with z equal to -1. Okay, check number 3 in just a second. And you're checking number 3. Hopefully you got m was equal to 16 by adding 4 on each side. Alright, so those properties of equality, we talked about the add and subtract. Basically, those were the inverse operations, or how we were going to isolate or solve for a variable. It doesn't change when we're talking about multiplication or division either. Okay, so if I multiply one side by 3, I have to multiply the other side by 3 to make it equal. If I divide one side by 5, then I have to divide the other side by 5. As simple as that. All right, let's put a couple of these to practice then. So take a look at number 7. What is happening to the variable we want to solve for? What is happening to t? T is being multiplied by 4. What is the reverse of multiplying by 4? Dividing by 4. And then I'm going to balance that on the other side of the equals. I've isolated the variable t down to 1t. And if I do the math over there, t is going to be equal to -8. Okay, pause your video and do number 8. Pause your video, do number 8. Okay, so hopefully your reverse was dividing by -5 and balancing it on the other side, and x being equal to 5. All right, well, let's practice one down here together, looking at number 11. On number 11, what is happening to the variable m that we want to solve for? M is being divided by 7. What is the reverse of dividing by 7? The reverse is to multiply by 7. We'll just have to disregard that 11 there. What happens when I take 7 divided by 7? I get 1. I've isolated the variable. But now, if I multiplied by 7 on this side, then I need to multiply by 7 on the other side to make it equal. So now I've got 1m, and m would be equal to 28 in this case. Pause your video and see if you can do number 12. Okay, hopefully you ended up with z equal to -100 by multiplying both sides by -4. Okay, now here's a quick reminder about a special problem where we have the variable, so let's look at number 14 here, we have the variable t being multiplied by a fraction 2/5. Okay, so the reverse of multiplying is divide, right? However, we don't divide by fractions. If you remember, we multiply by their reciprocals. So we're going to multiply that by 5/2. if I multiply by the reciprocal, right, multiplicative inverse, that was that warm-up we did earlier, I'm going to end up with 1, right? It's exactly what I wanted, was 1t, or isolating the variable, so I can solve for it. However, if I do this on one side, multiply by 5/2, then I need to multiply by 5/2 on the other side. Okay. Then what happens is I end up with negative 40 over 2, which is negative 20. Okay. Pause your video and solve for B in number 13. Okay, so hopefully your reverse was to multiply by 4/3 on both sides, which would get you 60 over 3, and reduce to 20. B equals 20. All right, so solving one-step equations. Let's make sure we back up and talk about equivalent equations. Equivalent equations means they have the same solution. Okay, and again, that's when we would add on one side and balance that on the other side, or multiply on one side, balance it on the other side. Okay, and that's going with these inverse operations. These inverse operations, which you can do with addition, division, multiplication, and subtraction. And then isolate. What does it mean to isolate? That means get it by itself. So when I isolate a variable, I want it to just be one of that variable, like 1x equals. Alright, so here is your assignment for 2-1, page 85. There's the questions. If you forget, then you can look at Schoology. Okay, have that ready to go when it tells you to have it ready to go on Schoology for questions.